Okay, stats. So one other thing we can do with grouped data we just did in central tendency is dispersion, specifically, unfortunately, standard deviation. So it's very similar to, we had to make some changes for the mean. So we need to find our class midpoint. We need to find the overall average. We need the frequency, and we need to square it because it's standard deviation, just like we did in 3.2. And then we have to multiply it by the frequency in the end and do our division. So I'm going to copy in the data from the previous assignment. This is what we did at the bottom of just on the previous video in 3.3. So I'm going to just copy the numbers in down here so that we can do this. Okay, so we had 3.5, 8.5, 13.5, 18.5, 23.5, 28.5, and 33.5 with their respective frequencies, which I can tell from this table: 130, 250, 230, 180, 100, 60, and 50. And we know for x bar is 14.75 for all of them. Because that was the average we calculated previously. So thank you. Previous video work. So let's get back to the task at hand. If you look in this formula, it says we need to take our times and subtract the averages. So 3.5 minus 14.75 is negative 11.25. Thankfully, these go up by 5 each time, so this is going to go up by 5 each time. So negative 6.25, negative 1.25. Be careful when you're adding 5 to this. 3.75, 8.75, 13.75, and 18.75. I don't know why my writing is so diagonal today. Must be because I'm actually sitting and not sitting on my knees, but I digress. Now I need to take those values and square them. So remember, to get this column, you take this one minus that one. I think it was slightly out of frame for a second there. So let's take 11.25 and square it. So it's 126.5625. Do the same thing with 6. 39.0625. Same for 1. 1.5625. Now we do it for 3.75. 14.0625. Do it for 8.75. On and on and on, all the way down. 76. 189.0625, and then finally 18.75. 351.5625. Now, we have to take this column and multiply it by the frequency column. The 130, 250, and so on and so forth. So 126.5625 times 130. 16,453.125. Okay, you can see the writing on the wall now. $97.65.625. 1.5625 times 230. 359.375. 14.0625 times 180. Oh, I typed improperly. Lovely. 14.0625. Let's try this again. Times 180. 2531.25. 76.5625 times 100. I could do this one. 7656.25. 189.0625 times 60. 11,343.75. And lastly, certainly not least, 351.5625 times 50. 17,578.125. Okay, we've got to add all these up. We know this adds to 1,000 because we did it before. 16453.125 plus 9765.625 plus 359.375 plus 2531.25 plus 7656.25 plus 11,343.75 plus 17,578.125. 65,687.5. What does the formula say we're supposed to do? We have to take that sum and divide it by the total number minus 1, because this is a sample. So the square root of 65,687.5 over 1,000 minus 1 is 999. So we do this. Square root of 65,687.5 over 999. So our sample standard deviation is approximately 8.109 if we're going 3 decimal places. Now, that's fun and great and wonderful and clearly time consuming, because even when I did it on this paper with just 7 entries, it took almost a whole 10-minute video. On the next page, this is how you do it with your calculator. This should be for the TI-30XS. Press data, enter the class midpoint, so you have to calculate that yourself. The frequency, second stat, press 1 variable statistics, your data be L1 and your frequency be L2, and calculate. Now, if the data is large, I believe that calculator will not let you enter frequencies that are larger than 99. Anything above 2 digits is out. So if you have something that's like 150 for the same number, you're going to have to do it 2 separate times. For example, 90 plus 60 is 150. So you're going to have to break it up into 2 pieces. But this should be all for 3.3.